So welcome everybody. This is the open forum of the IGSN 2040 project that is currently going on. And the purpose of this session really is to get as much community feedback into what is being or what is evolving in the vision of where the IGSN system is going to go, obviously until 2040. That's where the name comes from. But we are at a stage of planning in this project, and I'm going to talk a little bit about that, planning the future of the IGSN, and we really need to get some feedback from the community if that's or where the challenges may be, where the benefits may be of what we have in mind. So with that, oops, yeah.
There's one person online.
Okay, so are you taking minutes, Sarah?
Yes.
All right, so I'll come in. If I dial in, I can look after that. I'll just go to the minutes.
Okay.
It's too much to do with one full one.
So we have a very loose agenda for this meeting, and we're few enough people to let the discussions go in whichever way they evolve. I just wanted, for those of you who may not know about the project, give a brief introduction. And I apologize to those who were at my talk yesterday in the international session, because there's obviously some repeating of slides. And then we actually want to talk a little bit more broadly about persistent identifier systems and how scalable and how mature they can be and should be and so on. And then really open up for discussion, for questions, for comments, but also for getting from you requirements from your perspective of trying to implement the IGSN, using it in your community or setting up allocating agents and so on. So with that, a brief reminder to everybody how critical persistent identifiers have become for talking into this here might be better from my perspective. The relevance of persistent identifiers for fair data or for the fair data ecosystem, let's say it that way, because it helps us to build the connections to network information and data to make them findable and accessible and properly citable. And so this is, giving you the well-known identifier systems such as DOI for data sets, or for publications, or even for scientific programs, for cruises and so on, ORCIDs for the researchers. And basically the IGSN adds samples into this ecosystem, linking the physical objects to the various entities in this data ecosystem. The IGSN is actually a fairly old or long-term project that started in 2004 with funding from the National Science Foundation, and was initially developed as a centralized system that issued unique sample identifiers. But it was from the beginning on, it was clear that one of the big challenges was to make it an international effort and pull in a global community that deals with samples. So we initially worked through a lot of outreach activities, presentations at international conferences and so on, that triggered a lot of interest and really personal outreach to repositories, museums, and specifically also international research programs such as the International Continental Drilling Program and the Ocean Drilling Program at the time. Now it's the Discovery Program. So what it achieved was all these outreach activities that we actually got a group of international researchers and cyber infrastructure providers together at a workshop in 2011, where we basically designed a more distributed architecture that would be scalable and accommodate the needs of a very diverse community and a global community. And as a consequence of that workshop, we founded the IGSN organization. The EV stands for Eingetragener Verein, which is the German way of non-profit organizations. And we basically adopted the German way of governing non-profit organizations by becoming an EV. And following that, a broad set of distributed development started. Lots of developments in Australia and in Germany primarily at the time were basically local needs, local requirements were addressed in setting up allocating agents and functioning in the way these organizations needed the IGSN to be implemented for their organization. So this is just an overview sketch basically of how the IGSN organization works. There is a central IGSN registry that operates out of the German Geoforschungszentrum in Potsdam, and the allocating agents basically request namespaces from the central registry and register some level of administrative metadata with that registry and locally manage the metadata of the samples in catalogs that the allocating agents are responsible for. And each allocating agent has their user community of, be it researchers, be it repositories, and so on, that use the implementation that, you know, whichever software was basically custom built at the allocating agents to manage the metadata to obtain the IGSNs, register, not obtain, but generate the IGSNs and register those IGSNs at the central registry. The whole architecture was basically copied over from DataCite, including the governance structure. So we heavily copied everything, taking advantage of the example of a successful PID system. And it leverages the Handle system as the technical basis. So where are we now? We have close to 7 million samples registered. We have 8 functional allocating agents that you can see here. They are in 5 different countries, but there are other allocating agents under development right now, which will add France, the UK, and South Africa to the number of countries that have implemented it. And there is substantial interest in the community to take advantage of the IGSN. Several organizations are basically considering the use of IGSN, but these demands have basically led to this project that I was going to talk about, or that I will talk about, in that these are big organizations that bring millions, and in part, like the DISCO project in Europe, billions of samples into the system, challenging its architecture and performance. And it's also challenging the governance structure that basically our business model doesn't work anymore for supporting in a professional manner this international network of major organizations. So we started in 2000, well, actually before that, at various RDA meetings, we held bird of feather sessions and proposed an interest group on physical samples and collections in 2017 that was approved. then and has been meeting since then. And as a consequence, due to participation of one of the Sloan Foundation program managers in one of those RDA sessions, we were invited to submit a proposal to the Sloan Foundation and get funding to undergo this strategic planning effort to design a new organizational and technical architecture structure for the organization to ensure that it can operate as in a persistent manner, in a professional, mature manner in the future. So that planning effort is underway. We had it structured into 3 work packages and 3 phases, and we have gone through this first phase of information gathering with respect to organizational aspects and architectural design. We've had a survey, and if there is interest, Sarah Ramdeen, who is part of the project, can provide an overview of the survey results. And then we have this first phase of strategic planning going on right now. And we had a meeting of our technical steering committee in May, and tomorrow the organizational steering committee of the project will meet here in Tacoma and do a scenario planning for the organization to envision the challenges and the possible scenarios in which the organization will have to operate in the future and how it can strategically basically position itself and which changes are necessary to the organization. So briefly about the outcomes of the technical steering committee, and I will leave it mostly to Jens to talk about this. The technical steering committee in the first place set up a number of principles for how the IGSN should be operated in the future. Obviously, openness, be it with respect to participation, be it with respect to products, to software, everything being open for others to reuse, and again to participate. Obviously, trustworthiness is a critical aspect for the organization. A responsible management of samples and sample metadata. Transparency is important, non-discriminatory, standards-based, promoting best practices for sample management and data management. And it is an organization that is governed by its members. Some of the 4 kind of, I thought, most relevant recommendations from the technical steering committee included the separation of registration and description of samples that we have had until now. The registration has just a minimum set of metadata that goes to the central registry, while the description of samples sits at the allocating agents. I mentioned that already. An important move is the transition, or the recommendation to transition from XML-based metadata to a web architecture based on sitemaps and schema.org. Keeping services unbundled to minimize potential disruptions caused by maintenance and technology transitions, and the aspiration to automate services as much as possible to increase efficiency of operations. Jens, maybe, I mean, before I even get into, or let's skip the organizational maturity aspects for now, and, rather dive into the persistence, the sustainability of PID systems, and, both from the technical perspective and from the organizational perspective. So with that, I think I can switch over, right? And if there are any questions, please, we're a small enough group to. Yeah.
It's called the Internet. It's called the.
maybe I switched it on to avoid any interference.
Red is bad.
Hello. So it's called the International Geo Sample Number. And we heard in the talk this morning that most samples, like a huge majority, are biosamples. Are you going to grapple with biosamples at all?
So that's a really important point. And I did not mention it, that basically the IGSN has started to be used for other materials such as bioarchaeology and so on. And actually one of the biggest hurdles for adoption in other communities is its name. That people say, well, the geo, I don't want a geo number, right? So we have been trying to figure out how the acronym IGSN could get rid of the geo without having a completely new acronym. So we've talked about the interoperable global sample number, and so whoever comes up with the best idea, gets a free ride. The generic, yes. I mean, it's, we actually talked also at this technical meeting a little bit about should we leave different implementations with the geo face to the world, the bio face to the world, and so on, still using a common infrastructure. It's just the different flavor for different communities to give them sort of more ownership, feeling of ownership in it. That's something we can definitely continue to discuss, because that can very much inform discussions tomorrow at this steering committee meeting on, on the business model. If you can actually bring communities in that feel much more comfortable with calling it their biosample number or whatever. So I mean, any feedback from the audience on this issue is highly appreciated, I think.
One thing that I learned through being involved in PID efforts for quite a long time now is that branding is a really big issue. And even though the technologists always tell you there shouldn't be any meaning in the PID, and people still want something recognizable in there. So I want to give you a quick overview of some context around what the world in which IGSN exists, because it doesn't exist in the isolation. And the one of the question, of course, is why is it not a DOI? And the answer is for historical reasons, because I was involved in the project that developed DOI for data, and when Kerstin came up with the idea of IGSN, I thought this is brilliant, but it should be a persistent identifier. It shouldn't be this Caesar who knows where it goes. So I went to TIB Hannover and asked them, would you be interested in including samples into this persistent identifier framework? And they said, we love the idea, but it's out of scope. So we went our own way and put down the $50 to buy a handle namespace, which now people envy us for, because we have this top level handle namespace, which we maintain for $50 per year. So there's this historical background. And so over the years, we've been in discussion with DataCite. Should we merge? Should we come into the fold? Should we keep affairs separate? And over the years, we learned that the use cases for IGSN and the way we run services are sufficiently distinct from DataCite that it is worthwhile to keep things separate. And the discussions we had in Canberra, I think, reinforced that, where we saw that DataCite is a very focused operation that in this focus enables them to offer quite a number of value add services, very much around a bibliographical model, while IGSN is doing something quite different. But the systems are interoperable and they cross-reference each other. But in a broader context, how many PID systems are there? And I try to find out, and I say, I don't know. It's many. So one of the sources that I used was the re3data.org registry of research data repositories. They gave me an excerpt of their database of December 2015, back then when I wanted to write this paper. And in that particular excerpt, they had 1,381 repositories, of which 475 use some kind of persistent identifier. That might have changed until in the years since, but that was quite surprising. I thought there would be more that were using persistent identifiers. Of those, DOI were by far the most used ones. And what I've then found interesting is that so neither DOI nor Perl nor Handle nor ARC nor URN, there was a whole world of persistent identifiers that were used by 57 of these 475. So more than 10% of the repositories use some other identifier. And those were mainly disciplinary repositories, while in institutional repositories, they seem to like handles, which I think goes back to some of the softwares using the handle system to identify and index their holdings. So if you break down the numbers, that's what it looks like. The big bar on the left is DOI. So some repositories use more than one system. So that's why the numbers don't add to 1,300 something. Then there's Handle, the next one. Then the third one from the left is Perl. And then we have URN and ARC and other. So the handle-based systems are clearly the most popular ones. And then we have basically the other ones. And then if you break this down into disciplinary, institutional, and other categories of repositories, it becomes very clear that DOI is the most used in disciplinary repositories. It's also important in institutional repositories and the other ones, but then, as I said, many institutional repositories use handles because it seems to be part of the software that they use. And then in the disciplinary repositories, the other PID systems seem to be important. So that's something in the strategic development of IGSN and PID systems we should look at. Why is there this proliferation of identifiers in the disciplines? Maybe DOI is not serving them as well as they need. Maybe they have requirements that are not served by DataCite. An interesting year was the period 2015-16, when two of the PID systems had severe crises. So Perl was put into maintenance mode because the person that was running Perl at OCLC retired, and then the OCLC said, we're not longer interested in running this. And then it stopped, and then it got rescued by the Internet Archive. So Perl is back in operation, but it's not the, when you look at the number of repositories using it, it's not as important as it sounds. And pardon? Yeah, and that's one of the things when I'll look at the numbers on the next slide where they're being used. LSRD was a different story. It was always seen as really important, but then discontinued in 2016 because nobody could get it to work, and they didn't have a central resolver, and then they did come up with a central resolver at the last minute, but then it was already too late, and the system had no more support, and so the European collections, natural history collections, decided that they would drop back to using URIs, which Anton Günsch told me they are only a temporary measure, but we know that temporary measures can outlive anything else. We will see. But the lessons that we could learn from this is Perl had this crisis because it was basically a one-person shop, and so you need to have a broader base to be able to run a system like this sustainably. And once the institution pulled its support, that was it. Because it has a standing, it got rescued by the Internet Archive. And this might not happen with other disciplinary identifiers. LSID, on the other hand, was too complicated. It was banking on technologies that weren't there yet. Some of them never came. And then it just was impossible to implement. So when it's very difficult to get numbers, the easiest number to get is DOI registrations for DataCite. Today, it was more than 18 million. IGSN today had 6.9 million handle. I have no idea. No source URN, because URN doesn't have a central resolver. There's no chance to find out. LSID, using Google Scholar as a proxy, I found 14,000 mentions. There must be many more because they're in the collection catalogs, but they're not properly exposed. And Perl, I found through Google Scholar 16,400 mentions, of which 5,000 were digital objects and everything else were concepts and ontologies. And then when you look at what is being used, most repositories that have non-DOI or non-handle PID use DOIs or handles too. So all the repositories that have URN and ARC also run DOI. So
But it wasn't clear.
15 years ago, it wasn't clear that it would move that way. And so in the early days, we very seriously looked at URN as an alternative to DOI. But this is how things panned out. Maybe this is also the VHS versus Betamax thing, but that's how things panned out. And so the question is, what can we learn in terms of sustainability of these systems? And the examples of Perl and LSID, I think, are quite instructive in that they have very different causes for their crisis. But you can isolate on the one side the organizational aspect. Perl just didn't have the organizational backing, while LSID was just too complicated to be adopted. They were trying something that just didn't work at the time, and then 10 years later, everybody said, okay, we'll just drop this. So the other thing that I want to talk about is how we are going to scale the IGSN system. And Kerstin already said a few things about that. One of the discussions we had is, so we have 6.9 million samples, which is not bad, but when you think about how many samples get referred to in a paper, then there's many more samples to a paper than there are papers. And if we then scale this to everything, we can expect many more than 6 or 60 million samples. We can expect something going into the billions sometime in the future. So how would we do this? How could we scale by orders of magnitude? And on the other hand, we have a system architecture that has proven to be quite resilient and flexible and useful, where we have a federated system, one of the features is that the way we set it up is that it allows to assign IGSNs offline, and then you can mint them when you come back home and back to connectivity. So the vertical line from the little stick figure up to IGSN, it's all push services. There's no request response. It's you define the identifier and then you go and register it. And then for the metadata portal, we were using a harvesting mechanism so that you could harvest the catalog the way you and your community needed it. And allow multiple metadata schemas. So there's a single schema that everybody needs to support. There's a common ground, but then there's other ways that people can describe the samples and create catalogs. So what we did realize was that we needed to transition to new technologies, because this system was designed in 2011, but on technology that was slightly older than that, which was fine at the time, but not now. So in the current system, we use XML to encode metadata, and the XML schema to validate the metadata, and OAI PMH to then disseminate the catalogs through harvesting. And I forgot to put this here, we have a dedicated server to run these services. So what we envisage for the new system architecture is that the shape of the architecture won't change, but some technology bits in there will change, in that we will use JSON LD to encode the metadata using things like schema.org, etc. And then Shackle to validate the metadata, sitemap.org to make the catalogs available for harvesting, and then use cloud serverless architectures instead of the dedicated server. And in this way, we think we can scale from millions to billions of samples. And the tests that we've run so far indicate that this will work. And I think that's all I want to say for now. Did I miss anything? Any questions? Mark?
So the person online can hear you use the microphone.
Yep. Two questions. One, Kirsten mentioned the principle of separating the registration from the description. I think that's a really good principle. And in principle, DataCite has the same principle, but if we look at the history of DataCite, it's continually expanded its metadata schema, and it contains actually quite a bit of descriptive information. And I think that what was driving that was this view of identifiers as a discovery mechanism. And I honestly don't really understand that. And I understand the motivation for what DataCite was doing, but I don't really agree with it. And I'm wondering if you have thoughts or comments on that in a way to ensure that you don't have that same sort of metadata scope creep.
We did discuss the metadata at length over years. And for instance, we had this workshop in Los Angeles in 2015 to bring the biological and geo communities together to see if we could find a common schema. And there are different positions on that. And personally, my position on metadata is that you need to be sure what you want to communicate with your metadata. And if it's about describing an object, and the object can be something from anywhere in the solar system, I need to encode world knowledge. That's going to be an absolutely monstrous schema that will serve no practical purpose. And I don't see how this is happening. If your purpose is to serve bibliographical metadata to enable discovery of data sets in the sense of a library catalog, that's where it came from, based on the ISO standard for library catalogs. If that is your purpose, you can do that. And what we did see in DataCite was a certain scope creep because there was enough demand. So there was a 10-year discussion about adding geolocations because the geo community wanted that, and now we have it. And
yeah, I just want to say, just to talk a little bit about DataCite metadata and scope creep. We still have only 6 mandatory metadata fields, and we added one in 2016. So we've been really aware of that, of keeping that mandatory metadata very slim. So for what it's worth.
So it's there if you want.
Exactly.
Right. Then my second question was, how do these offline IGSNs work? How can you ensure that you're getting a number that's unique when you're offline and you're not plugged into the system?
yeah, so namespace governance is the theme here, and it depends on how you grew up and where to find a fitting metaphor to explain how it works. So to Australians, I refer to the Wikipedia page on car license plates because it explains how namespaces work for car license plates.
Basically by
It's in Australia, it's a federal system, but each state has some sub rules on how they then deal with the namespace they have been allocated in the license plate space. Telephone numbers would be a different thing. Like when you start with the international access code, then you have your regional whatever area code. And in the old days of mechanical exchanges, you could go down to the last numbers and see which suburb this was in. And then there were 4 digits or less that would be the actual subscriber line. And then you would have maybe an exchange board at a company that split things even further, and that the telecom would not care about what the company did within their local network. IP addresses is a similar delegation mechanism where somebody gives you a namespace and then you can do within that namespace. That is up to the agent to see how they handle that, and then ARDC I think has different methods. For instance, ARDC offers individual registrations and of samples, and there it's a request response mechanism. In dealing with that particular client agent relationship, as a client you request and you get a response. In CSRO we have all sorts of different things. One example for the field allocations is that we preprint the numbers. So in the old days, they had little booklets like raffle tickets printed for the particular campaigns, and then they would tear out the numbers and put them in the sample bag. So we basically just digitized that with QR codes that then could be scanned in an app. But the principle is that there's namespaces and sub namespaces, and it's up to the agents to make sure that this is all unique. I think it's not on. You have to press for 2 seconds. Is battery flat?
No. In CSAR, it's a fairly heavily used feature that people pre-register their samples. It's a danger, I have to say, and you know, it brings to me all the time back the question of what's mandatory with metadata, and can you really hand out an official IGSN already after that? Because many times people just have a sample name or not even that in their pre-registration, and they do not come back to complete the metadata. We had to build at some point, we have this batch uploading tool where you can register, any number of thousands of samples if you want to. And it was basically way too difficult for people then update the metadata one by one. So we established a service that allows metadata update, just using the former batch template and filling in metadata and then uploading it. But there's, as long as you don't enforce certain policies, many of these samples stay very poorly documented. And I see that as a let me just talk into the microphone. One of the what we realized in one of the last RDA sessions that we ran about physical samples and collections, the biggest insight was that these type of questions of how do you establish the right procedures, the workflows, that was the biggest concern of everybody. And that's what the organization really needs to take on and have, Joan is in the midst of this, and maybe you want to say a little bit about that. Implementing it for a community, giving guidance on how you actually get the IGSNs, what metadata matter, and so on, is a really big concern that we need. And currently there is no real policy for mandatory metadata, and in CSAR, when it was initially the centralized system, it was kind of impossible to enforce mandatory metadata. I remember, and I've probably told the story before, that one of the first museums that registered their entire collection was the Harvard Museum in 2005. And there was not a single geospatial coordinate for the whole collection. You talked about georeferencing samples this morning. So if I had said, okay, without geospatial coordinates, I don't take the samples, we would not have gotten these 50,000 samples into the IGSN. There are always, reasons why certain information is not available. So, but we do need, and I'm thinking specifically on the role of publishers now, or their recommendation to use IGSNs to make metadata about samples persistently accessible from a publication. If the metadata profiles of those samples are just not populated, we're going to run into, I think, questions of quality. And that's where, Jens mentioned, the vast number of IGSNs out there that, for samples that may not have data in a publication. The important step is to have good metadata once the IGSN goes into a publication and becomes sort of a public link to information that we sell as the special feature of the IGSN, that you will find out where is the sample now, how can I access it, and so on. And if that is not provided in the metadata profile, that becomes a problem. So going back, I think we, all the allocating agents will need to think how they can ensure good metadata profiles, and that sort of these offline pre-registered samples actually have good metadata over time, or improved metadata. Oh, that I don't want to pull anything down here.
Jens, thank you. So looking at your next generation architecture based on JSON LD encoding schema.org types of methods, how is the IGSN system as a whole, the global system, going to interface then with those different allocating agents? I mean, is it very much the, register yourself in some way as that source, start publishing your information using those methods, have a small set of mandatory fields within the information that's provided, and then that's your way of advertising it to the world, and then it's a matter of anybody who wants to leverage and tap into that going out and hitting your system and pulling that information? Or is there still a sort of like, how do you envision the actual point of minting, so to speak, in the DOI sense happening, I guess?
So the minting is only somewhat related to the schema.org and etc. metadata question. So if going back to this diagram, the minting process is in that vertical column, and it's all push services. And in this case, we can keep it XML. It doesn't matter so much.
So that's going to remain that part of the process.
We might also have a transition period because the services now are set up to work with XML and REST, and maybe we need to run 2 different services there. But that whole string is very lightweight because it deals only with 4 elements, which describe the registration process itself. The description of the sample, the really rich metadata, comes in that side branch, which is within the field of the agent, because the agent knows where the sample is, deals with the clients, deals with their community, and with the ways they want to describe the samples. And so what we identified here is the OAI PMH is really an outdated technology. It was lightweight in the ages of harvesting 5,000 catalog entries from a paper repository, but it's not suitable for disseminating catalogs that are millions of samples, or tens of millions or hundreds of millions, that you can't do with OAI PMH. So that's where the sitemap thing comes in. So the idea here is that the central level, the top level, has the list of sitemaps that it points to at the agents, and the agents then have sitemaps, and then pointing to the metadata embedded in the landing pages that describe the samples.
So the assumption, though, is that every IGSN has some construct of a landing page, some place that you're going to go and you're going to get that sort of information in some kind of a response, whether it's going to be structured for harvesting machines who are trying to index all of that stuff together to be able to hit and do their work. Okay, but it's going to be, I guess, where does the sitemap come into that, though? Because I mean, if you have the IGSN registration stack happening, you have a dereferencing point that IGSN is going to. Why do we need the sitemaps? What do the sitemaps play?
The idea here was that if we do all of this at the top level, you need to harvest all 3 billion samples. It turns out to be that big, but nobody will want to do that. And not only because it's hard, but because it's of no use. Because we're not talking about only geological samples here, we're talking about anything. And somebody doing material science will not be interested in tissue samples necessarily, or rocks. So somebody who wants to get the catalog of the 100,000 mantle xenoliths will not be interested in harvesting the 10 million tissue samples from mice cancer, whatever research. And in this way, by not centralizing all of that information at the top, we make it more lightweight and more flexible to adapt to the discipline-specific requirements.
So where's the registry of sitemaps?
Sorry?
Where is the registry of sitemaps then?
That will be at the top level,
Okay.
the registry of sitemaps.
Okay. So you register both the individual IGSN with the little bit of information needed to dereference it and the sitemap that IGSN is a part of.
It's the sitemap of sitemaps.
Okay.
So at the top level, it's the sitemap of agent sitemaps. So then on the agent level, there's this pairing of IGSNs and the site landing pages and the sitemap. But at the top level, it's basically the meta inventory of sitemaps.
Okay.
Just to emphasize that the workshop only happened 2 months ago, right? And this is the time to actually, provide feedback on this. If you see, problems in the implementation from your perspective and so on. So I'm totally happy to listen to any concerns that you may have in the implementation or in this design, that is evolving. I mean, this is clearly, there has to be, over the next year of this project, an iterative process between the sort of organizational aspects of, managing organizations of very different scale in the system. So, there are allocating agents that obviously may have billions of samples versus small allocating agents that just deal with, 200,000 samples and so on. And we need to accommodate that both in the business model and in survival mode, right? And in the technical design too. So I think, we will refine what we have created in a 2-day workshop so far, right? I'm more than happy to hear this discussion now and see, where do we need to invest more attention, I think, to refinement.
No, I think the basic paradigm for going in that direction makes complete sense, and getting away from the OAI PMH thing and all of that makes great sense for how we interact with that part of the catalog. I guess, but question, was there an expectation in the planning that the thing on the other side of that sitemap listing of stuff would be a human readable landing page? Or is the expectation that that thing is a machine readable landing page essentially, which might have a human readable component? I mean, it could, content negotiation or whatever, decide, oh, well, I'm going to give you some HTML and you can read it and has a nice picture of the sample and everything. But in other cases, it might not be that entirely. It's just a bunch of URL pointers that get you to, the human readable metadata that might get slurped up into something other. Okay.
Yeah, so until now, we always had it as a rule that there has to be a landing page that describes the sample. Also because it is human readable, and that would be within the responsibility of the agent or the client, whatever their relation is. But that would also that landing page would also have all the rich description that wouldn't be in the centralized catalog. In the discussions that we had now, we assumed that we want to keep and still have a human readable landing page, but that we want to add the machine readability through content negotiation.
So I personally would look at it a little bit differently than that. But in the system of billions of things out there, many of them are going to be perfectly reasonable to go look at and explore as a collection of items that you want to see a little snippet of information associated with them, and then dig a little bit deeper. But some of them are going to have, rich information that you want to present to a human being who's looking at it on the other end. But I personally wouldn't think that it's necessarily a rule at that scale that, every one of those has a web page that you go and visit as a person.
I mean, in most cases, the web pages would be generated on the fly
Oh
anyway.
yeah, well, it's not a matter of, them, really serving a major function. It's just, it's an interesting assumption to go into it with.
Oh yeah, I just had one point of clarification to ask. So if I hit the top level IGSN endpoint in this new system that you're discussing, would I expect to get a machine readable, if I was a machine, get a machine readable file in a consistent format, no matter which of the 3 billion samples I asked for, or would I be pointed to something that is designed at the agent level?
So what you would normally do is you would then go to a handle resolver, and that would redirect you to the agent or client level, whoever is responsible for serving that page.
Right, but that would be a machine readable format that's designed at that level. So there wouldn't be like a schema.org or something representation that's common, or would there be?
It will be something that will be a community consensus on what it will look like. Schema.org is not rich enough to do that.
Okay, thanks.
Thank you. So just, I want to make sure I understand what agent is. I'm assuming that's allocating agent.
Yep.
So, and this is speaking from just my experience.
In the data side terminology, it's an allocating agent. Because we don't have the allocation. It's not you request and get allocated, you register. So that's why
But
anyway.
an agent is representing a group of organizations.
Yes.
So from my experience of putting that kind of social business model construct into your system architecture, it's going to tie your hands down the line, and it can become a problem in that you have a really hard time changing a business model because you've baked it into your architecture, and that becomes difficult. But I mean, Kirsten and I have talked about this a lot, and I'm a little sorry to see that of baking that in at that level.
Well, that's the discussion we had until now. So tomorrow and the day after tomorrow, we'll have the meeting of the organizational steering committee who are to discuss the business model and the social model.
But so again, I thought we were discussing the system architecture in the 2-day workshop. So just a little feedback on that.
Yeah, so having the technical workshop before the organizational workshop was a bit putting the cart before the horse, but that's how it went. And so the original idea was to have the organizational workshop first to give the parameters for what the technical system then needs to support. Now it happened the other way around. So this is what we tested, some technical concepts to see, would it be possible to implement those business models? This is not a decision that this will be the business model. It's showing that it's technically feasible to do it.
Yes, so I suppose just to comment on a couple of the threads, I agree there is a conceptual sort of choke point there on saying, unless you've got a web page there that a human could read, and you could imagine in quite a lot of cases, actually, particularly with samples, that you'd need to have the identifier, and you may not have a lot of descriptive information there, or that the descriptive information is not necessarily applicable.
Or it's not even there yet.
Yeah, that's right. So, or that the page doesn't exist, yet. So I think, we need to just, take that on board, but that probably gets back to the point that we were just at there, was that you need to kind of clarify some of the key objectives and then design systems and business around those objectives, or at least be clear around them, saying, for example, data cite kind of has the mission written into the title there, that this is data and it's the citation part of data, and that's why those 6 elements are the appropriate ones for the purpose. And as you said, for information, it never stops unless you've got a purpose. So we potentially need to identify some of those purposes and say, for this particular purpose of being part of that, the original diagram you put up there with, being a part of that world of linking to publications. Here's an appropriate bit of information for us to be part of that world.
And that's a very good point, because I've been wanting to say this, that we also need to look at the life cycle, and data sets offer comes at a fairly late stage of the data set's life cycle, when there's a publication, when the data set is published. That it can be used in different ways, but traditionally, and when we look at how it's handled in the context of FAIR and COPTAS, etc., we at the point of publication of the paper, we want to have the supporting data online identified with the persistent identifier. So there we have gone through a long vetting process from your private domain, where you had many versions of your data set floating around. Some of them you shared with your colleagues, collaborators on this paper, and then a subset of that gets into the final publication. And I think we see something very similar in samples. You collect lots of samples in the field, because this is maybe your last chance to go there. And then you will work with a subset of those, and a subset of those will make it into the publication. So the question is, if we assign IGSN at the end of that process, then we have rich metadata and maybe not so many identifiers. But some people say it's actually very useful for us to use IGSN as tracking numbers to see follow things as they move through labs, so in CSIRO, working with Geoscience Australia and the state geological surveys and the universities, we have this case that samples get collected by, say, the Geological Survey of Western Australia, then move through the labs of Curtin University, and then through labs at CSIRO, and then they go to University of New South Wales, and then somebody publishes on them. Having this tracking number is very useful, but the metadata that we have with this object might be a bit sparse. So is it then the policy of the identifier system to say you must have full and rich metadata right from the start, or is it policy of the publishing system, the editors, to say you have to have rich metadata when you want to include the sample in your publication?
So anyway, it's to reflect on some of those purposes. If we make the purposes clear, that a tracking and is a great thing, actually. And as you say, even without a global metadata portal at the moment, there is no global metadata portal for all the IGSNs, but people are getting great value out of the numbers and having anyway, so tracking is a good thing. Potentially the linking into literature, but again, that's a secondary, it's another purpose with a different set of information. And I think Kirsten mentioned another one, which is not an information systems function, but something that IGSN could really do is be that place where the conversation around, good practice in metadata sample management or information management for metadata samples, and sharing that kind of thing. So that's yet another sort of function that that we could outline for the organization.
And I have to say that the original purpose when I proposed this development in 2004 came out of the project of putting a geochemical database together. And it really was that issue that you had data for the same sample in multiple publications, and the sample had different identifiers in each one of those publications. And trying to link data across the publications to one particular object, that was the first major component of it. The second one was actually to advertise samples, to make samples more accessible, right? And that's when you actually starting to need good metadata, right? So in the program manager who has been funding this from out of NSF over the last 10 years or so, was really keen on sending her PIs to us and saying, you need to register your samples so that others can find out these samples exist, and people don't need to go back to that location or hire a ship again to dredge on the specific rice, because there already are 5,000 samples from that location, right? And that's where I'm always torn with, the aspect of how rich do metadata need to be, because if you have catalogs such as, at AIDA in CSAR, it's nearly 5 million samples. If we don't have good metadata, you do a search for basalt and you get 50,000 or 100,000 samples back, and it's difficult to make good decisions and actually discover what you're looking for. That so I think the challenge for us is, besides finding a good technical solution, is really implementing these type of policies and best practices and distinguishing between the different uses of the IGSN. As you said, as long as it's really just tracking a sample in the lab, it's a very different use case than, basically advertising a collection or something like this, and the publication and ensuring access to sample metadata and so on. So I've been thinking a lot actually about this, step of putting an IGSN into the publication, that we need services for validating metadata that align with community requirements or requirements from publishers and so on, to say, I want, if an IGSN is used in the publication, I want a full set of metadata. And I've heard from some communities the relevance of knowing access policies of the sample at the repository, permits, referring back to where the sample was collected, that it's not, we have a lot of diamonds, for example, in our system. People want to know where are they responsible diamonds, and so it goes into very very specific and rich information that makes a sample acceptable, or an IGSN profile acceptable. I think that's a huge challenge for the future.
Yeah, maybe just to reiterate that whole thing about purpose, that in the DOIs for data, I'm still struggling through some dynamics of multiple purposes ultimately for those DOIs, from internal, not the DOIs themselves, but essentially the process of determining that it's appropriate to mint this identifier and the associated information with it, and the practice behind managing the thing that it's identifying. It's really all of that that's included there with data. I mean, we're struggling through right now with our policy in USGS, where we implemented it and we said, we actually got into these details of, here are the points where data being updated needs to trigger the creation of a new digital object identifier versus going back and updating the information associated with this other identifier. And we're having an interesting argument about all of that right now of, well, if the purpose is to, create now this immutable object that we cite in a paper, then obviously if we need to come back in and make a correction in the data for that, it's a whole new thing. It's a whole new object, and it needs to be have a new DOI assigned, and there might be a new relationship created. This thing is now withdrawn and it's been superseded by this thing, and all that other stuff that needs to go on. But that's difficult to implement to a great extent for the folks who are managing data, who essentially say, well, yeah, I want to get this thing done, and I'm identifying this data set, but it's obviously going to change in the future, and I'm going to need to add new stuff to it, and I don't want to have to go back and manage another thing and then have to tell all of my friends that I have this other DOI and go through this whole process of it. And so what it boils down to at the end of the day is we're using that system and the process that we've built around it for two very different purposes, and they run into conflict with each other. And going clear back to like the San Diego meeting when we got together and worked out a bunch of this whole thing with the IGSNs, right? I mean, we had a bunch of those things in mind. We said, well, we really want to try to push this whole process as far back upstream as we can so that the IGSNs get established early in the life cycle of these samples and that they're used operationally all the way through. And we wanted to design, a system that could be conducive to physical labels to put on boxes and all that other kind of stuff that drove a bunch of the technical design of it. But, if you are re-envisioning this for 2040, I think getting better clarity on what those business rules are and what the real purpose of the system is, and being able to clearly articulate the 2 or 3 things that it's really designed to solve, I think will really help drive, how we implement it operationally.
I just want to strongly echo that. We have a fair amount of discussion about this in the revised data citation guidelines, which are quite different than this, but it's grappling with those issues as when do you get a new DOI and stuff. And then in the subsequent conversations that we've been having in the research object citations cluster so citation is generally been defined, CODATA defines it, I think, pretty nicely as a mechanism for access and credit. And those two concerns are often at odds with each other. And credit is very much a human sort of thing, and access is very much a machine sort of thing. So I think that's really critical as much as you can, because I think with data, we made some false assumptions early on about it being kind of similar to literature. And it's really not at all similar to literature. And now we're sort of dealing with those consequences. So if you have this opportunity now to really not only determine what the purposes are, but I think, as Skye said, clearly articulate them so people understand that what the purpose is, and that it's not necessarily a credit mechanism. Maybe it is, but I mean that to scope that all out very precisely, and probably get it wrong, but it still would help.
In my experience with just working with researchers so far, I'm in community engagement for Earth and Environmental Science Repository. It seems to me that one of the main goals for people in standardizing their data and their metadata is to be able to have a central place to look for similar data. And so I was just wondering, like, are there specific plans to have a central place to look up IGSNs? And I mean, the standard metadata is essential for that, and that is the incentive for people, I think, is to be able to do that, to be able to search.
So the idea in the original design to use OAI PMH was that this would be a mechanism that allows to disseminate not just one schema, but any community agreed schema in parallel. But there would be one schema that everybody needs to support, so we could build a central catalog of everything. But then there would be community portals for more specific cases, like the basalt example. At the moment, in the standard metadata description that we have, there's basalt. If you work on basalt, this is useless. So the basalt community would need a different set of metadata to, say, the ones working on sediments related to hydrocarbon production. And I think that this is a very this is something that I want to keep as a principle, that we should have a mechanism that allows both the federation of the catalog of everything, which I think serves a fantastic political purpose, but very little practical purpose, and the creation of community-based, quite specialized catalogs that serve the community that makes the distinction between country and Western.
I kind of think, I don't know, I guess I kind of like the catalog of everything where you could sort of filter it to see what you want to see. Because one of the big problems that we have.
The question is, how would you describe anything in the catalog of everything?
Yeah, no, I know. It's hard. Yeah, well, you could have, yeah, it's like you imagine you have the current metadata kernel, but you're talking about getting rid of that. I don't know how you would do it. My comment was going to be, it just seems like the allocation agencies are each going to have to come up with their own standards for richness, and that's going to have to be something that's translatable to like resolvable, so publications can query, so they can say, we have these samples, we can resolve these IGSNs, and according to the community, they have rich enough data. But it seems like once you, no, that doesn't solve the other problem at all. I think it's tough just because like it's good to have centralized repositories. And if you have 1 billion repositories for like roughly related samples like basalts versus hydrocarbon rocks, like those are sort of in the same neighborhood. And so if you're just a geologist looking for rocks, if you have 100 different sample repositories, it's hard to know where to look. And it would be nice to simplify that. But obviously it's a significant technical problem too.
Yeah, and then for that reason, I thought that if we opened up the API to allow harvesting of different catalogs tailored to the needs of different communities, that would then make it a little bit simpler, that as the basalt guy, you would go to the basalt portal, and then you would find the information you need from the 12 basalt databases that you need to access.
Well, I think this has been a long discourse between Jens and me, because I'm also more of the larger aggregation fan, because I wanted, from the beginning on, was this idea that you can search across all these collections without having to know, which collections may or may not have samples that are relevant to you, and I mean, I do understand a lot of the technical and social aspects of this, and I really wonder, how far we can have these special, I don't know, community profiles attached to that core record, and you basically can create a bit of a hierarchical categorization in some way that allows you to say, well, I want basalts, but there is, with under basalts, you have categories of mid-ocean rich basalts or something, and dive into metadata of those. It's a big gap right now for the IGSN. Still is obviously ontologies and vocabularies that brings some consistency across all the different allocating agents and would allow a better search. I mean, we can talk about metadata fields, but I think just having the content then also in a more consistent way is becoming an issue. And ultimately, all these discussions take us again to our challenges in actually building all this, finding the resources to do that, because it's right now the business model is that every allocating agent looks after their own resources. So it's in some cases it surveys or research organizations like CSIRO. In some cases, it's projects like CSAR that is NSF-funded activity with limited time, and limited resources that will need to be augmented all the time. So that's the challenge really of implementing the top level activities, and that's really the discussion that we're heading towards tomorrow, to see that the organization can actually take on more of these top level tools and services of vocabularies and so on to serve its allocating agents in a better way. That's not trivial, I think, to do that. Oh, we're 5 minutes to 3. Wow.
One quick comment on this last discussion. There's a working group in RDA that's put out a recommendation on, what's it called? PID kernel information. And in trying to develop that, we went through this, much of these same discussions. And, ultimately there is no, you think there's at least common denominator, and there isn't. So instead we came up with principles that would guide with some of these things that I think would provide some, be useful in this regard. And that's actually out for public comment right now. So it would be good to get your feedback on that.
Although the PID kernel working group focuses very much on machine readable.
It's very much on machine readable.
Yes.
It is really the kernel of the handle record that is for the machines. But when you're talking, it's, I think it was in Berlin. Tobias Weigel. Yeah.
That's a good point.
You need to talk into the mic still.
Okay.
But the discussions in that working group really illustrate what you said, that even when you say, oh, we only want to describe what should be the handle kernel for machine readability, does that help with this? All we discussed now was discoverability, but what's in the PID kernel does not really aid discoverability so much when you talk about the catalog of everything.
Sorry.
No, I don't think it doesn't get you to the catalog of everything, but it helps machines start down that process of being able to sort through billions of objects. And then, then there's going to be layers on top of that.
Yes.
And those layers are going to depend on different communities and different purposes and so forth.
And it's a very bad place to end, but it was just getting back into some of the details of the scalability of some of those processes. So I'll try to be general about it. I think that was Kirsten's comment, is that the technical model that was presented is kind of a direction. We haven't really tested that, and I don't even think that the whole schema.org, JSON LD, sitemap, web crawler architecture has really been tested even over in the there's a whole session going on today around discovery and science, what's it called? Science on schema or something like that. So they're still sorting that out as to whether, Adam and,
Adam and Doug.
And Doug, yes, they're still grappling there as to how you might use that same architecture for data discovery. And I'm not 100% sure that, so some of the things I think that Sky was bringing up, there could be, once we have our purposes a little bit clearer, it'd be good to actually go back and test that architecture. The example that just came to mind was that if I want to know, whatever, even a small piece of information about a sample that might be required for one of our purposes, if I have to get a web crawl, if I have to get a web crawler and go through all the samples, etc., and find the sitemap, etc., that's quite a lot of, that's putting a lot of requirements on the end user. So
I'd say no, because that's where I saw the role of the community portals to provide services there. But I think in the interest of time, we have to continue this discussion. So,
I mean, thinking about the meeting tomorrow and the day after, I really want to come back to what Tricia said earlier, that ultimately the IGSN needs a business model that allows it to operate in the long term. And, what has been brought up in discussions is this model, as you said, with just a few agents that run services for broader communities, having its challenges to actually bring in enough resources to operate the organization. And we really need to keep our minds still far open to figure out how we need to revise this structure because I mean, obviously we can come up with wonderful models here. If we don't have the money and the sustainability for the operation, we can forget about it, so I think the architecture needs to be open-minded towards the business model more than the other way around. That was basically what I was trying to say, right? And I hope that, Leslie, yes.
Actually, while we've got everyone here, I was just going to ask the question, does anyone know of another group that's got something fairly entrenched in XML that's wanting to make this swap over? Oh, don't laugh. Hey, Mark, do you know of anyone?
I should, but I can't think of anybody else. I know people are struggling with that.
Yeah, that's what I'm thinking, that in a way we're trying to do it, but our core schema is pretty simple, so it should be a good one to make this change, but we know we have to make this change because already the granularity at which people want to apply these things, and we know this, they want to get down to mineral grains and zircon mounts and individual grains in a zircon mount. So the number of sample numbers that people want is going like that, but the number of agents is in a way dropping because everyone's combining together.
Right, because the current business model makes it cheap to just be, that's exactly the point.
The data side
where we need to, figure out ways, and it's also, in many ways what you just said, the challenge of moving from XML to JSON, or, just technological changes that may be required for this will challenge some of the allocating agents. That's the other thing, we can't go up in contributions from the allocating agents because many will say, sorry, can't pay that. And also, well, if you make all these changes to the architecture, we don't have the resources to implement that. So that's another aspect in moving on into a new phase of the IGSN that we need to take into account, and how we can potentially build components of this system that can be just adopted or taken by allocating agents and implemented locally to allow them to plug into the broader system. And I'm thinking specifically as an example of the data one nodes, right? That has been a structure where it was fairly easy for you as a repository or so to participate in this network. And I think that's another aspect that we need to take into account. How implementable is the architecture. I know.
Yeah, so just,
Scarce
I know we're out of time, but one of the constant critique still around the IGSN system, again, is that there is no kind of faucet at the end of the plumbing, so to speak. I mean, it is just a lot of back-end plumbing to make this whole thing happen, and it's great that we have that. But you know, I do think that as a community, we should figure out how to get a couple of maybe not killer apps, but at least demonstrative apps out of this thing as we move it forward. And maybe at two ends of that spectrum of, you know, somebody should just build the total search engine, look across everything. I mean, there's no reason we can't do that, and that'll stress test the system and all that kind of stuff. And the engaged community that'll go in and say, well, okay, we'll create an index of this subset. Maybe it's looking across 5 or 6 different allocating agents and getting 80% of this collection and 20% of that one and whatever else in order to produce, you know, this thing that's very specialized and all of that sort of thing. Totally different domains, whatever, and then, but, you know, driven off of the same,
it's
you know,
actually
infrastructure. Right?
Because it's not a complicated schema, basically, of, you know, building those interfaces shouldn't be too difficult.
Let's see if one of them could be done at the level of like a Funding Friday funding, you know?
Yep.
$10,000, build it.
Well, I wanted to thank everybody. I think this was a very useful session from my perspective in getting, you know, questions and comments about where we're heading, and gave me at least a lot to think about and to take into the discussions over the next 2 days with respect to, you know, real world applications of what we're trying to envision here and design. So thank you all, and, you know, stay in touch. Obviously, RDA meetings will have their physical samples, but that's not only IGSN. And, you know, we always have a meeting of the IGSN organization on the Sunday before the AGU fall meeting starts, trying to run an hour or two open door for anybody who wants to come in, and we will announce that again for the upcoming AGU fall meeting. Okay, so thanks everybody.